continue with the addressing modes of 8051. So 8051 already we have seen it is a 8-bit microcontroller. So what is that 8-bit represents? It's the capacity of your ALU. Right? So at a time we can process 8-bit of data. Okay? So in this class we will see first start with the addressing modes of microcontroller. So from the name itself, addressing mode is nothing but how we are going to provide the data in an instance. Okay? So whether it can be taken from a register or it can be taken from a memory location or it can be given directly. Okay? So broad classification of addressing mode. First one, immediate addressing mode. Second one is direct addressing mode. Third one is register addressing mode. Fourth one is register indirect addressing mode. Fifth one is implied addressing mode. Okay? So first one, immediate. From the name itself, immediately the data is given in an instruction. So normally the instruction will have the symbol hash. Okay? So if I say move a comma hash 10 means here that hash represents that the data is immediately available in the instruction. So here 10 is the data that has to be assigned for the register. Okay? Similarly you can write move r1 comma hash 20. So whatever be the destination, we have to put it after the mnemonic. So the general format of any instruction is first we have to specify the mnemonic, then we have to mention the name of the register or we can say the destination, and the third one will be the source. Okay? So next one is direct addressing. So from the name itself, directly we have given the address where the data is placed. Okay? So here if it is a DPTR, it is a 16-bit register, or if it is an 8-bit, we can mention either in R0, R1 or R2. Okay? So move a comma 10. So if you clearly notice the hash symbol is missing here. Okay? So if I provide the hash in an instruction, it indicates a data. If the hash is missing, it indicates a address. So move a comma 10 is nothing but whatever be the content present in the memory location 10 will be moved to the accumulator. Okay? So similarly you can write so many combinations. Move r2 comma 20 or move 20 comma r2. So the destination can be any direct address. So source can be a direct address or the destination can be a direct address. Register addressing. So how many registers are there in a microcontroller? So we are having R0, R1, R2, R3, R4, R5, R6 and R7. Okay, so we are having so many banks. How can you switch over the banks? Which register is used for this? So we are having a flag register, nothing but the program status. Okay, so in that we are having RS1 and RS0. So if the combination of RS1 and RS0 is 0, 0, it will point to bank 0. Okay, if it is 0, 1, it will point to bank 1. If it is 1, 0, it points to bank 2. If it is 1 and 1, it points to bank 3. So by default, it will point only to the bank 0. Okay, so if I say move a comma b, so what happens? The source is one register and the destination is another register. So the content of b will be moved to the a register. But here if you notice, we cannot move data between two registers, that is R0 to R7 directly. So if I say move R1 comma R2, it is illegal in microcontroller. We do not have any such instruction of that type. Okay? And fourth one is register indirect addressing. So indirect, as I said, for immediate, where the hash symbol comes along with the instruction, here the at symbol will come into picture. Okay? So move a comma at R0. Right? So here whatever be the content present in the R0 will be loaded into the accumulator. Okay? So here at, after at, only two registers are allowed, R0 and R1. So we cannot go for at R2 1. So it can be in any place. Okay? It can be in the destination or it can be in the source. For example, move a comma at R0, or we can say move at R1 comma a. So like that, we can indirectly specify where the data is present. And similarly, last one is implied addressing. So implied is where the destination and the source are the same register. So for example, if I say complement accumulator, so here we have to take the content of the accumulator swap A. Okay, swap means we are going to exchange the lower nibble with the upper nibble, but the source and the destination gives you only the accumulator. Okay, so before I conclude, what are the addressing modes we have seen? So first one, immediate addressing, then we are having direct addressing, then we are having register addressing, then we are having register indirect addressing, and we are having finally implied addressing. So now we will see how to write a program using the various addressing. Okay. So as I said, the first addressing mode is immediate addressing mode. So move A comma hash 10. So if you see, the instruction has the symbol hash. So here what is the meaning for this line? The value 10 has been assigned to the register A. Okay, similarly the value 20 is assigned to the variable or the register. Okay, now add A comma B. So here the first path is the mnemonic, the destination and the source. Right? So now the two contents present in A register and B register are added together. The result will be in A register. So if you add 10 and 20, the answer will be 30, and you can store it in the memory location using a DPTR, that is a data pointer. So move DPTR comma hash 9000, that is the DPTR is initialized as 9000 here. So move X at DPTR comma A. So here the variable X indicates that the external memory has been used, and whatever be the content present in an accumulator will be stored in the destination specified. And there is no hard statement, we use normally SGEM states for short. Similarly, the same program, how it has been addressed using a direct addressing mode. So first line, just initialize the DPTR as 9000. Move A comma 10. What's the difference? If I put a hash symbol, it is a data. If the hash symbol is missing, it indicates a address. Now, whatever be the content present in the location 10 will be moved to the accumulator. So here 10 is nothing but your RAM number. Okay. Similarly, take the content from 20 and keep it in R2 register. The same data for easy purpose, we can assume that the data present here is 1 register. So the memory location contains the value 10, and similarly the location 20 contains the value 20. Now add together, add A comma R. As I said, mnemonic destination comma into the media. Okay. So now already we have stored the added value. Now it's time to store the carry. So increment in media. Now move a comma r2. Why can't we directly go right into x and media comma r2? So if we are moving any value to external memory, it has to be done only into the accumulator. So first we have to bring the carry value to the accumulator, then perform the storage operation. So architecture of 8051. So later we continued with the instruction set where we have seen the instructions regarding the arithmetical operations, okay, addition, subtraction, multiplication, division, right? And we have also seen the sample program how to perform addition and subtraction, multiplication and division, okay. Then after that we have seen the logical operations like and, or, not, exa, right? So what is the mnemonic for performing AND operation? So it's AND. Okay, so normally in the processor we have AND, but in microcontroller if you see the mnemonic for performing the AND operation is ANL. Similarly to perform OR operation we have ORL, and to perform the XOR operation we have XRL. So what about the instruction for performing the complement? So we are having, we can say CPL, right? So CPL accumulator, right? Then what else? So now we'll move to the next instruction of how to push a data into the stack and how to remove it from the stack. So in microprocessor itself we have seen the two instructions called push and pop. So push is nothing but pushing into the stack. Pushing something means push the data into the stack, and similarly pop out means take the remove or retrieval of the data from the stack. So what is the difference between a push and pop in a microprocessor and a microcontroller? So if you see in microprocessor, so the microprocessor in the stack pointer is 16-bit in microprocessor. However, in a microcontroller, so the stack pointer is only a 8-bit. Okay. So here by default the stack pointer will be pointing to 07 in microcontroller. Okay. So when you push any data, so what are the steps it will follow? First it will increment. Okay, so anyway we have to push the data into the stack, means we have to move it to the next location. So the next location will be 08. So now we have to load something into the stack. Similarly, if you are going to pop out something, means the step will be first it will decrement and take the data. Okay. So what is the syntax? So if you say push, then we have to mention the name of the register. Okay, so the content that is present in any register, only the name of the register should be specified in an instruction. Or if you are going to use any direct address, means we can mention the direct address along with the instruction. So push 40. So here if you write an instruction like this, push 40 means it will take the content from the 40 memory location and put it into the stack. So similarly if I say pop 40 means it will take the data from stack and put it into the memory address 40. Okay. So next instruction we have is rotate instruction. So what are the possible rotate operations? So we have rotate it in the right and rotate it in the left. Along with the carry also we can perform a rotation, right? So we can say RLC and RRC. So the main difference is if we are rotating without the carry won't come into the picture, right? So the LSB will move to the first position and similarly it will rotate. Okay. So the rotate instruction, the mnemonic for performing the rotate operation is RLC. Okay, so if the carry C letter comes along with the mnemonic, means the carry also should take into the account. Okay, so however if we are not going to include the carry, means what about the instruction? So we can write RLA, simply RLA, okay, or RRA. Okay, so imagine that we are having a 8-bit data, and if you are going to rotate it into the left without the carry, means so the leftmost bit will come and sit in, that is the MSB, 7th bit will be come and sit in the 0th bit rotation. Okay, this is your rotate left. However, if you are going to rotate it the data into the right direction, means so the rightmost data, that is nothing but your 0th bit will come and sit in the first position. So in both the cases, whether it may be a rotate right or rotate left, if the carry is not included in the instruction, so the no data should be moved to the carry. Okay, so here if it is a RLC or RRC, if you mention the mnemonic
along with the carry, so the carry should be come into the account. So if you say RLC means the content of the accumulator should be rotated in the left direction inclusive of the carry. So that means your MSB will move to the carry and the carry bit will come and sit in the 0th bit. Okay, so similarly if you perform RRC, okay, so the rightmost bit will go to the carry and the carry will come and sit in the first position. So can you guess why we have all the rotate operations? So why we need a rotate instructions? So simply what you are gaining just by rotating the data? Okay, if you imagine that the data, let us assume that we are having the 4-bit data, okay, 1 0 0 0. Okay, if you perform a rotate operation in the right side direction, what happens? That means the 1 will come to the next position and 0 will go there and the last 0 will come out. Now if you see the data, it will become 0 1 0 0. That means first initially before rotation it was 8. Now after rotation in the right direction for one time it will become 4. And similarly, if you rotate in the right direction another time, what happened? That 1 will move to the next location, taking the data as 0 0 1 0. So similarly, when you rotate for the third time, what happens? That 1 will come and sit in the last position. That means it will become 0 0 0 1. Okay, so initially the data was 8 and after one rotation it was 4 and after that it will become 2 and after that it will become 1. So now what you observe by just seeing the data like this? 8, 4, 2, 1, right? That means we are continuously decreasing or dividing the value by 2. So that is the main advantage. So if you want to divide any number by 2, there is no need to write the division program, right? So simply we just get the data and rotate it in the right direction one time. Will obviously divide the data by 2. Similarly, if you want to divide it by 4, what you can do is just rotate the data 2 times. Similarly, if you want to divide the data by 8, so we have to rotate the data 3 times. Okay, only in the right direction we will perform the division operation. So can you imagine what will happen if you rotate the data in the left side direction? Obviously the reverse, right? So right side, if you are performing the division operation means the left side it will perform a multiplication operation. So imagine that 0 0 0 1 is the data, initial data that we have given. So and if you rotate it in the left direction for one time, it will become 0 0 1 0. And if you perform the left rotation another time, it will become 0 0 1 0 0 1 0 0, right? And similarly for the last time it will become 1 0 0 0. So initially it was 1, then it was 2, then 4 and 8. So we are having 1, 2, 4 and 8. So continuously it keeps on multiplying by 2, right? 1 into 2, 2, 2 into 2, 4 and similarly 4 into 2, 8. So just remember that if you rotate the data in the right direction, it will divide the value by 2 and similarly if you rotate the data in the left side direction, it will multiply the value by 2. Okay. So next thing. So the next instruction we have is branching instruction. So the very first and the foremost branch instruction we have is jump. Okay, jump and call. So what may be the difference between a jump and a call instruction? So jump instruction normally transfers the control within the program itself. Okay, so we can transfer the control from line number 1 to line number 5, or we can have a backward jump from line number 10 to line number 5. So here there is no need to store the return address. Okay, so there is no need to store anything into the stack. However, if you go for a call instruction, we are going to transfer the control from a main program to a subroutine. Okay, so there we have to store the return address into the stack. Then only the microcontroller will know from where we have to continue. Okay, so imagine jump 2000 means, and if you are having in the statement, let us assume that we are having in the line number 2000, okay, and we are going to transfer the control JC L1. Jump if carry is equal to 1, go to that L1. That L1 statement may be in 2005 memory location or it may be in 2000A location, right? And similarly, you can have a JNC. Jump if there is no carry. So similarly, we can have a conditional jump for all the flags we are having. So already we have discussed what are the flags available in a microcontroller, right? So we are having carry flag and we are having an overflow flag, then we are having a parity flag, then sign flag, right? and we are having an auxiliary carry flag also. Okay, what is the difference between a carry and an auxiliary carry? So carry is nothing but the carry that is coming out of your 9th bit, right? 8th bit line வெளியில வருது, it's a carry, right? And similarly, if it is an auxiliary carry, so it is nothing but half of your carry. So if a carry propagated from 4th bit to the 5th bit, now we say auxiliary carry. That is, if the lower order nibble is greater than 9, we say auxiliary carry exists. Okay. Then what else? So call means call sub address. Okay. So if I say call 2000 means, so the before you transfer the control to the subroutine, the microcontroller will store the return address after the next address after the call into the stack by using a push instruction. So that will be taken care by the call opcode. So operational code. So each and every instruction will be having an opcode. The microcontroller won't understand whether if you say jump or call. So each and every instruction will be having an operational code. So it can understand only the machine language, right? So if you perform the opcode of a call, it automatically understands that we have to transfer the control to a subroutine. Okay, so before transferring the control to a subroutine, it will store the memory address of the next instruction after the call into the stack. And similarly, if you have a call, obviously the pair will be a return statement, because we have to come back to the main program and start executing from where we left. Okay, so each and every subroutine will have a RET statement. So a return statement will take back you to the main program. So it will continue from the next line of your call instruction. So if you see, call instruction is a 3-byte instruction, and in microcontroller we are having a 2 types of call. We are having an absolute call and we are having an L call. Okay, long call and absolute call. Similarly, if you see a jump instruction, we are having a S jump, A jump and L jump. Okay, A stands for absolute. Okay, and S means short jump and L means long jump. Okay.